As we stand on the precipice of an unparalleled era, our world is undergoing constant transformation due to an intangible and potent entity. This entity, recognized as generative artificial intelligence, operates subtly beneath the daily interactions and creations, and even influences our understanding of reality. This sophisticated branch of AI is endowed with the ability to generate a wide range of outputs, including text, images, music, and other forms of media. The magic of generative AI is rooted in its intricate generative models, designed to duplicate the complexities of reality and to imbibe the intricate patterns and structures of the data they're trained on, thereby enabling them to create new content bearing similar characteristics. Generative AI is not simply a theoretical notion, but a concrete technology signaling a revolution across a multitude of sectors, such as art, literature, software development, healthcare, finance, gaming, marketing, and fashion. All these industries are being redefined and recalibrated through the powerful lens of AI. However, with great power comes the potential for misuse, and generative AI is no exception. The potential risks include cybercrime, the spread of disinformation, and the creation of unnervingly realistic deepfakes. These issues have ignited an intense debate around ethics and regulation as we strive to tap into the formidable power of AI while ensuring its responsible use. As we delve into this enlightening video, we intend to navigate you through the fascinating cosmos of generative AI. Tracing its origins back to the 1950s, when the concept of machine learning first emerged, we'll explore its evolutionary journey, marked by significant milestones and game-changing breakthroughs. One such landmark event in the history of generative AI came in 1986 with the introduction of the Hopfield network, a form of recurrent neural network. This was followed by the advent of the Boltzmann machine, another type of generative recurrent neural network. The narrative of generative AI's evolution would be incomplete without the mention of restricted Boltzmann machines in the mid-2000s, which contributed significantly to the development of deep learning. The present state of generative AI is dominated by generative adversarial networks, GANs, introduced in 2014. These networks are programmed to produce new data that is almost indistinguishable from the original. We'll also discuss the fervent debates surrounding its implications, its potential impact on society, security, and privacy, and the future prospects of this ever-evolving technology. So, strap in for an exhaustive journey into the domain of AI. Let's uncover the revolutionary world of generative artificial intelligence, a formidable technology that is poised to reshape our world and our future. Generative artificial intelligence, or GenAI, is a compelling subset of AI technology that has revolutionized content creation across different media forms. These systems, powered by generative models, are trained to understand patterns and structures, which they then use to generate new data bearing similar features. Over time, two significant types of generative models have come to the forefront: generative adversarial networks, GANs, and variational autoencoders, VAEs. GANs work on the principle of two neural networks challenging each other, one creating fake data to fool the other, which tries to distinguish the real data from the fake. On the other hand, VAEs use a completely different approach. They are based on the statistical method of Bayesian inference and probabilistic graphical models for generating data. The evolution of generative models has been marked by significant advancements, most notably the development of transformer-based deep neural networks in the early 2020s. These advancements have led to the creation of several robust generative AI systems such as ChatGPT, Copilot, Bard, and Llama, which are widely used for chatbot applications. There are also systems like Stable Diffusion, Midjourney, and DALL-E, which are primarily as text-to-image AI art systems. These generative AI systems have an uncanny ability to respond to natural language prompts, opening up a world of applications across varied industries such as art, writing, healthcare, finance, gaming, marketing, and fashion. The developments in this field have been quite rapid, showing the immense potential of generative AI and its potential to shape the future of content creation. As we introduce the concept of generative artificial intelligence, its various applications, and the emergence of impressive generative AI systems, one might ask, how exactly does this technology work? To answer this question, we need to take a closer look at the mechanics of generative AI. Generative AI systems function based on what are known as generative models. These models serve as the foundation, which is trained to comprehend and replicate the patterns and structures of the data they are exposed to. Designed around deep learning algorithms, particularly transformer-based neural networks, these models can understand the complex relationships between different elements in the data. So, how does a generative model learn? Consider this. The training process involves feeding these models with vast amounts of data. This data could be text, images, or sounds, or any other data type that aligns with the model's intended use. The more diverse and comprehensive the training data, the better the generative model's ability to create high-quality, varied outputs. This is because the model learns to identify patterns and structures found within the data, even when they are not explicitly programmed to do so. A process often referred to as unsupervised learning. But how does a generative model generate new data? Once trained, the generative model can take a seed or a prompt. This is processed through the learned structures, enabling the model to generate an output that aligns with the patterns it has learned. For instance, a text-based generative AI like ChatGPT, when given a prompt, can generate a continuation of the text that remains contextually relevant and mimics the style of the original prompt. Different generative models specialize in different types of output, each with its unique use. For example, DALL-E specializes in generating images from text descriptions, while OpenAI Codex is designed to generate programming code based on natural language prompts. This versatility of generating such diverse outputs is the core of what makes generative AI an exciting and transformative technology. As we move forward, we will trace the historical development of artificial intelligence, exploring how these generative models have emerged and evolved over the years. The inception of artificial intelligence can be traced back to the groundbreaking work of Alan Turing. In 1950, Turing penned the seminal paper, Computing Machinery and Intelligence, which posed fundamental questions about machine reasoning in relation to human intellect. However, the evolution of the concept was slow-paced due to prohibitive costs and technological barriers. A turning point came in 1956 with the Dartmouth Summer Research Project, which served as a catalyst for 2 decades of swift progress in AI research. This pivotal event was spearheaded by John McCarthy, Marvin Minsky, Nathaniel Rochester, and Claude Shannon, who collectively birthed the term artificial intelligence. Their conference set the groundwork for AI as a field of study, tackling fundamental problems in AI like natural language processing, problem solving, learning, and perception. In the 1960s, a major breakthrough was the development of the first AI chatbot, Eliza, by Joseph Weizenbaum. This marked a significant stride in the simulation of human conversation. As AI began to infiltrate the world of art in the early 1970s, Harold Cohen's creation, Aaron, an AI program capable of generating paintings, marked AI's first step into the realm of creative expression. His work demonstrated that AI could also potentially possess artistic prowess. Another key figure in AI was Andrei Markov, who made significant developments in the early 20th century on Markov chains. This mathematical system enabled text generation based on learned patterns, a crucial advancement in the AI field. Advanced machine learning techniques like deep learning started to gain traction in the late 2000s. However, the initial was on discriminative models due to the intricate nature of generative modeling. In 2014, the advent of variational autoencoders and generative adversarial networks, GANs, pioneered by Ian Goodfellow, brought to the forefront practical deep neural networks capable of generating complex data, particularly images. This marked a significant leap in the AI landscape, as it allowed for original content generation. The AI landscape was further transformed in 2017 with the introduction of the Transformer network. This breakthrough laid the foundation for the development of GPT-1 in 2018 and GPT-2 in 2019 by OpenAI. These models demonstrated impressive unsupervised learning capabilities, highlighting the remarkable strides taken in AI's evolution. The year 2021 witnessed landmark advancements in the field of AI art with the introduction of DALL-E, Midjourney, and Stable Diffusion. This represented a revolutionary turning point in the technology, which now enabled the generation of high-quality, refined art through AI, guided by nothing more than natural language inputs. The underlying technologies that power these systems are truly state-of-the-art. They use advanced machine learning algorithms, sophisticated language processing, and cutting-edge generative models to transform text inputs into rich, vibrant images. This is not just about the aesthetics, but also the profound impact they have on various sectors. The capacity to generate art using AI has opened up fresh avenues in the creative industry, fostering innovation and pushing the boundaries of what is deemed possible. These technologies have blurred the line between human creativity and machine precision. They have not only changed the way we perceive and create art, but have also ushered in a new era of visual communication. The introduction of GPT-4 in March 2023 ignited a flurry of discussions about its capacity as an early prototype of artificial general intelligence, AGI. Academics argue that while it's a remarkable development, generative AI is still a considerable distance from equating to general human intelligence. Generative AI encompasses a vast range of modalities such as text, images, audio, video, molecules, robotics, planning, and business intelligence. Correspondingly, it opens up possibilities for revolutionary applications across a plethora of industries, from healthcare to entertainment. The swift and exponential growth of generative AI, however, has simultaneously given rise to several ethical and societal issues. The potential for misuse is alarming, with concerns revolving around cybercrime, the propagation of fake news, and the production of sophisticated deepfakes. These possibilities have led to worldwide discussions, underscoring the urgent need for regulations to ensure AI usage. More specifically, critical challenges linked to job displacement and ethical implications are coming to the forefront. The potential for generative AI to replace human labor in various industries creates a legitimate concern for employment rates and economic stability. Ethically, the ability of AI to mimic human behavior and intelligence raises questions about privacy, identity theft, and the blurring of reality and artificiality. Biases inherent in AI, financial implications, and the rapid and uncontrollable spread of deepfakes are also significant areas that are demanding immediate attention. The potential for AI to perpetuate existing biases, causing discriminatory and unfair outcomes, has been a contentious issue. Furthermore, the financial implications of generative AI are dual-sided. While it promises efficiency and cost reduction for businesses, it can also lead to economic disparities if mismanaged. Efforts toward regulation involve proposed legislation and voluntary agreements that aim to address a myriad of issues, including copyright infringements, content labeling, ethical usage, and transparency. Through these measures, it's hoped that the benefits of generative AI can be harnessed while mitigating the associated risks. As we draw to a close, one cannot deny the immense potential that generative AI carries. It holds the power to revolutionize industries, from healthcare to manufacturing, opening up avenues that we've only dreamt of so far. Picture a world where personalized medicine is a norm, precisely designed and accurately delivered to suit each individual's unique genetic makeup. Or imagine the manufacturing sector where AI-powered robots work seamlessly alongside humans, increasing productivity while significantly reducing errors. However, the journey to this AI-powered utopia is riddled with multifaceted societal challenges. To mitigate these challenges, it's essential to take proactive measures. Efficient strategies need to be adopted to address potential misuse or abuse of this powerful technology. This, therefore, calls for stringent regulations. We need a strong regulatory framework that governs the use and application of generative AI. The regulations need to be robust enough to keep a check on any misuse, yet flexible enough to foster innovation. But more critically, ethical considerations will play a prominent role in the AI narrative. As we continue to delegate decisions to machines, it becomes of utmost importance that we ensure these machines are not just smart but also ethical. The generative AI applications of the future must respect privacy, uphold fairness, and be transparent in their operations. Therefore, as we stand on the brink of this AI revolution, it's crucial to tread with caution and a strong moral compass, ensuring that the technology serves humanity without compromising our fundamental values. The future of generative AI is indeed promising, but it's imperative that this promise is delivered ethically and responsibly. As we look ahead, the future of generative AI unfurls as both promising and challenging. The rapid advancements in this field are anticipated to transform every facet of our existence, from the way we communicate and create to our business operations, and even how we perceive ourselves and the world. Generative AI is set to enhance its capabilities drastically with leaps and bounds in precision, scalability, and versatility. This could mean a substantial increase in the quality of content generated, the ability to create more extended sequences of text, or larger, more detailed images, and the capacity to handle tasks with greater complexity. We can foresee a plethora of advancements within this sphere. For instance, we might witness the emergence of new applications, such as AI-assisted creative writing, where the AI might suggest thought-provoking storylines, or even assist in creating poetry. Similarly, generative AI could help in designing unique architectural structures, or composing music that can captivate the audience. These applications have the potential to democratize creative activities, making them accessible to a wider audience, and opening the floodgates to a new wave of innovation, imagination, and creativity. In the business, generative AI could become an invaluable tool for companies, helping them simulate multiple scenarios and predict their outcomes accurately. This could enable more efficient operations, superior risk management, and a substantial increase in profitability. Imagine a future where a business could foresee market trends or customer preferences, leading to better, more informed decision-making. Furthermore, within the realm of science and technology, generative AI could turbocharge research by generating hypotheses, designing experiments, and analyzing results. For instance, in the field of medicine, it could propose new treatments or anticipate the spread of diseases. In physics, it could help model complex phenomena, and in engineering, it could aid in developing more efficient systems. This could lead to groundbreaking discoveries and advancements across various disciplines. However, as we stride into this future, we must also brace for the challenges that generative AI brings. We must address crucial ethical concerns such as job displacement due to automation, safeguarding data privacy in a rapidly evolving digital landscape, and the potential misuse of AI-generated content for malicious purposes. Furthermore, we must ensure that the benefits of generative AI are distributed equitably, with its development being guided by principles of fairness, transparency, and accountability. In conclusion, the future of generative AI is a voyage into uncharted territory, a journey that is laden with immense promise but also fraught with significant challenges. As we embark on this journey, we must navigate with wisdom, foresight, and a profound sense of responsibility. For the decisions we make today will profoundly shape the world of tomorrow. Thank you for watching. Remember to like, comment, and subscribe for more technical discussions. Until next time, comrades.